Welcome to trigonometry. Okay, this is the basic trig stuff that we're going to look at this week. A lot of this should be familiar from days in geometry. And if you remember basic trig, it has to do with SOHCAHTOA. I don't know if you remember that or not. But SOHCAHTOA is a silly mnemonic device we use to remember the three basic trig functions, which are sine, cosine, and tangent. Okay, sine, cosine, tangent, abbreviated what looks like sin, cos, tan. Okay, we actually call it sine, cosine, and tangent. Okay, now SOHCAHTOA, what does that have to do with everything? Well, it talks about the three trig functions. They're hidden in there, right? Sine, cosine, tangent, s, c, and t. They're all hidden in that SOHCAHTOA. And then the other letters in there, the A, the H, the O's, those talk about the different side lengths in a right triangle. And so we use trig, this is called right triangle trig, when you're looking at an angle measure, okay? And so for the unknown angle, okay, it can be represented with a letter. Sometimes you might see this Greek letter called theta, which is like, sorry, I tried to draw it, but it wasn't very good. Sometimes theta is represented like that. It's like a zero with a little squiggly in it. Like I said, it's a Greek letter used to represent an unknown angle measure a lot of the time. So if this is our angle that we're dealing with, the A, the O, and the H all represent the three side lengths of the triangle. You see, you have, to every angle, there is an adjacent side represented by A. Right? You guys know what adjacent means? It means next to. Okay? So this side here across the bottom is next to this angle. And I know what you might be thinking. You might be thinking, well, Mr. Johnson, there's another side that's next to the angle. You're right. There is another side next to the angle. However, this is the hypotenuse. Okay? The hypotenuse is never the adjacent side. It's always the hypotenuse side. The hypotenuse is the hypotenuse because it is across from the right angle. Every right triangle has a hypotenuse. And so in all of these, we'll be dealing with a hypotenuse side and then your adjacent side. And then that leaves the O for the opposite side. Okay? Adjacent, opposite, and hypotenuse. So the trig functions, sine, cosine, and tangent, relate those three sides to each other. So take, for instance, up here on SOHCAHTOA, the S for sine. Sine is going to relate the opposite side over the hypotenuse side. Right? That's why we have O and H as a part of that SOHCAHTOA. So sine equals the opposite side length divided by the hypotenuse length. Cosine equals the adjacent side length over the hypotenuse side length. A and H, right? And then the last one, T for tangent. Tangent equals the opposite side over the adjacent side. So O and A, right? So we're going to take those three functions here and apply them down here in 1 and 2. We're going to write out the ratios for these different angles, okay? So starting with number 1 here, we have a right triangle with points A, B, and C, okay? Three different side lengths here, 7, 24, and 25 are already written in. We're going to start by doing the sine of angle A, okay? So that means we're going to go to angle A, and we're going to relate, since it's sine, we know we have to do the opposite over hypotenuse, okay? So the opposite side from angle A is clearly 7, right? That's across the triangle, it's opposite. So the opposite will be 7 over the hypotenuse. The hypotenuse here is 25. No matter which angle you're dealing with, whether it's angle A or angle B, 25 is your hypotenuse. That ain't changing, okay? Now, let's look at the next one. Next that, it says cosine of angle B. So cosine is A over H, right? If you go back to SOHCAHTOA, that means we need to look at the adjacent side divided by the hypotenuse side. Now, like I just got through saying, the hypotenuse side is always, in this triangle, 25. That ain't changing. What will change are the adjacent and opposite sides depending on what angle we're dealing with. So we're looking at the cosine of angle B, which means we're looking up here. So in relation to angle B, the side that's 7 is now the adjacent side, and 24 is the opposite side. Those are going to change, right? When we were dealing with angle A, 7 was the opposite side. So for cosine of angle B, it'll be adjacent side, which is 7, over the hypotenuse side, 25. So catch that. Sine of 25, or sorry, 7 over 25 is the same as for sine of A and cosine of b, right? It's the same deal. Okay, let's go down to sine of b now, the next one. So this time now we're using sine of b, angle b, opposite over hypotenuse. Okay, so in relation to angle b, the opposite side is 24, and the hypotenuse is 25. Now tangent of a. This time tangent, I'm going to erase those references again. Tangent is opposite over adjacent. So go to angle A. The opposite side is 7, and the adjacent side to A is 24. Okay. Next, we have cosine of angle A. Cosine is adjacent, the adjacent side over the hypotenuse side. Okay, so go up to angle A. What's my adjacent side here? That's going to be 24 because my hypotenuse is 25. So cosine of A is 24 over 25. And then tangent of B, it's the last one there. So go up to angle B. Tangent is opposite over adjacent. So we want the opposite side from angle B. That would be 24 divided by the adjacent side. That's going to be 7. So the tangent of B is 24 over 7. And that is our last one that we have for first triangle. Okay, good. Now, number 2. Same deal, different triangle though. We have A, B, and C. The hypotenuse side of number 2 is 15. That's the H, that's never changing. What will change are the adjacent and opposites, depending on if we're looking at angle A or angle B. Alright, let's start with tangent of A. Tangent of A, opposite over adjacent. In this particular problem, the opposite side from A is 9, the adjacent side is 12. So we get 9 over 12. Now, simplest form of that would be 3/4 if we reduced. So you can write that in there. Going down, tangent of B is just the same relation, opposite over adjacent, but the sides are different, right? So for B, the opposite side is 12, and the adjacent is 9. This simplifies to 4 over 3. What you should notice is that when you're dealing with the same trig function, you're just flipping, right, the top and bottom. There's reciprocals there when you're dealing with tangent of A versus tangent of B. Okay, maybe you've picked up on that pattern. That's cool. Next, sine of angle A. Sine is opposite over hypotenuse. So the opposite side from A is 9. The hypotenuse is 15. 9 over 15 reduces to 3 over 5. Okay. Cosine of A. Now to the top of the next column. Adjacent over hypotenuse. Adjacent side to A is 12. Hypotenuse is 15. 12 over 15. 4 over 5. Okay. Sine of B. Opposite over hypotenuse. So the opposite side from angle B is 12. The hypotenuse is 15. Hey, same as above. 4 over 5. Also, what you should notice is that cosine of one angle and sine of the other angle, that's going to be the same thing. Okay. And cosine of B, last one there. Adjacent over hypotenuse. The cosine for B is 9. That's the adjacent over hypotenuse 15. 9 over 15 is 3/5. Okay. Good. All right, that's the basic setups. Now, oftentimes we apply it to word problems. Now, before we get into actual word problems, we're going to just look at some diagrams here where we have to find the value of x. So x in all of these is a missing side length, right? Boom, boom, boom. It could be an opposite side, an adjacent side, a hypotenuse side, but that's going to depend on the angle you're dealing with. Whenever you start solving a problem like this, you always start with the angle that you're given, not including the 90, okay? So here we have a 63-degree angle. And I want to evaluate the two sides. How do they relate to this 63-degree angle? So the x, the unknown side over here, is my opposite side, right? Clearly that's opposite from the angle. And then down here is my 50 side length. Now, is that the adjacent or hypotenuse? Well, if we look where the 90-degree angle is, we can see that this is going to be the hypotenuse side. So here's what that tells us. Since we are dealing with the opposite and a hypotenuse, we want to use the trig function that uses opposite and hypotenuse. In this case, that would be sine, right? Opposite hypotenuse. And the way you set these problems up is you write sine of your angle measure, which in this case is 63, equals whatever your opposite side length is, x, over your hypotenuse side length, 50. And so you're going to do that. And now you've created a simple algebraic expression or equation that you can solve. Sine of 63 equals x over 50. So to get x by itself, like I would do any other problem, I need to get that 50 to the other side. I'm going to multiply by 50. So 50 times sine of 63. You can do that on your calculator. 50 times, now on your calculator you should have sine, cosine, and tangent buttons, okay? Especially if it's TI-30. If you're using an Inspire, you'll have to hit the trig button, and then the different functions will pop up, sine, cosine, tangent, okay? So 50 times sine of 63, I'm typing that in right now, should give you 44.55. Okay? Now, one disclaimer about this. We talked, no, we didn't talk in this class about that. So, sorry, that was a different class I was thinking of. Your calculators need to be in what's called degree mode when we're working with this kind of trig, okay? And I'll show you guys that in class, but on your calculators in general, there's different modes you can change it to. So if you have a TI-30, at the top row next to the second button, there's a button that says DRG. Go ahead and hit that. And you have 3 different modes you can choose from: degree, radian, or gradient. And those are going to just different settings. We want to be in degree mode for everything we do here, okay? When we talk about the unit circle, we'll talk about what radians is and kind of why that matters. But here, just make sure your calculator is on the degree mode setting, or else you're going to get wild answers, and it's going to confuse you. Let's go to number 4. All right, so the angle we're working with, right, that's where we're going to start, is 67 degrees. Then evaluate the two sides. How do they relate to it? Well, this x down here is the opposite side. Okay. Then the 26 up here, that's across from the 90-degree angle, so that's the hypotenuse. So again, we have opposite and hypotenuse, so we're thinking sine. So you should write this out as sine of the angle, which is 67, equals your opposite side over the hypotenuse side. And so once again, to solve for x, we just need to type in 26 times sine of 67. Let's go ahead and do that. 26 sine of 67, you should get, bada bing, bada bang, 23.93. Okay, good. Let's go down to number 5. So the angle we're working with here is 25 degrees, right? It's in the bottom left corner. How do the sides relate to that angle? Well, over here, the x, that is your opposite side. Down here, 15, that is your adjacent side. It is not across from the right angle, which is not the hypotenuse, right? The hypotenuse will be up here. So we are dealing with opposite and adjacent. That's the tan function. So we want tangent of 25 degrees equals x over 15. So to get x by itself, we want to do 15 times tangent 25 on your calculator. Type that in, and you should get 6.99. Okay. Good. So we've got 3 answers down. 1 to go on this page. All right, last one. Our angle here is 32 degrees. This x is the adjacent side. This 24 is the hypotenuse side. For adjacent and hypotenuse, we want to use cosine. So cosine 32 equals the adjacent side over the hypotenuse side. Set that up. And once again, to get x by itself, we just got to take that 24 and move it over. So 24 times cosine of 32, type that in, you should get 20.35. Okay? All right, good job on the first page of the basic trig notes.